So we've learned about the law of demand. Price goes up, quantity demanded goes down. As the price goes down, the quantity demanded goes up. The topic we're looking at now, the price elasticity of demand, answers the question, how much does the quantity demanded change when the price changes? Okay? So we're going to be looking at the price elasticity of demand. There is also a price elasticity of supply, although in this class we're just going to focus on the demand side, but it's a very similar concept. And so it allows us to understand, imagine you're a business and you're thinking about a price change, right? And you're wondering, will I have extra revenue? Will I lose revenue? Well, revenue is price times quantity. So if price is going up, law of demand says quantity is going to go down. Quantity demanded will go down. But if the price goes up by more than the quantity demanded goes down, then you could actually win. And the answer to that question then is, what is the price elasticity of demand? So as a formula, what it's basically meaning, what it's trying to capture intuitively, what I wrote there is a funny looking E, which stands for elasticity, and then a little D to indicate its elasticity of demand as opposed to elasticity of supply. So the basic idea behind the elasticity of demand is the percentage change, I'm using a little triangle delta for change, the percent change in the quantity demanded as a ratio to the percentage change in price. Okay, that is in a nutshell what elasticity of demand is. Okay, so this first thing to get in your mind is the numerator is answering how much the quantity demanded is changing as a percentage in relation to a particular change in price. So if you're told, and we'll work on this a little bit more, but if you're just given a figure, elasticity of demand is 2.5. What does that mean intuitively? Okay, well, it means that this numerator denominator solution is 2.5. So essentially what you're going to be able to say then is you would have a 2.5% change in quantity demanded every time you have a 1% change in price. So when you are given a number for elasticity, in this case 2.5, this is how you interpret it. That for every 1% change in price will be in this case, 2.5% change in elasticity. If the elasticity of demand that you were given was 0.5, then that's telling you that there's a 0.5% change in quantity demanded every time there's a 1% change in price, okay? So that gives you some idea of what the measure is trying to tell you. When you're given a measure of elasticity, a particular number like 2.5 or 0.5, then this is how you interpret it. A 1% change in price will cause a 0.5% change in quantity demanded if the elasticity of demand is 0.5, okay? Now, we're going to show you how to actually calculate the elasticity of demand. So let's look at that next. So percentage change means we're going to be doing the percentage change formula. It's a very good formula to know because you can use it for a lot of things and a lot of statistics and business reports and that sort of thing. If you're looking at a trend of numbers over time, it's good to know the percentage change formula. And so in general, it is value of the second period minus value of the first period as a percent of its original value, the value in the first period. And since that will result in some sort of decimal, you usually multiply it times 100, if that's what you need to do. So I'm showing you that just so you understand that this is in general how you get the percentage change. So one of the questions we're going to have here is if we were looking at a particular demand curve and we have one price, I'll call that one P2, which will go with Q2, that's 1 point on the demand curve, and we're wondering what the elasticity is in this range here, and so I'll call that one P1 and that one Q1. Okay, which one of these is value in the first period? Which one of these is the value in the second period? You don't necessarily know, but what's most important to realize is it's going to make a difference. Your calculation is going to make a difference depending which one you choose. So let's just look at the numerator, all right? Because you'd have to do the percentage change in the quantity demanded for the numerator and the percentage change for the price for the denominator. So just focusing on the numerator for now, the percentage change in quantity demanded, depending on if I'm going from P2Q2 to P1Q1, or am I going from P1Q1 to P2Q2? Which direction am I going? So depending which one I choose, I could end up with two different calculations for the percentage change. I could have the percentage change in quantity demanded be equal to Q2 minus Q1. So using my formula up here, that means I need to take it with respect to Q1 times 100. Or I could end up with Q1, so now I'm making that the value in the second period, minus the value in the first period. And so now I'm going to take it with relationship to Q2 times 100. Okay, that would give me the percentage change. So what I'm wanting to point out to you is we want to have one measure of elasticity for a particular pair of points on the demand curve. This is showing me that I have to be careful with what am I going to do on this value in the first period, second period. This numerator here is going to come out the same. They're going to be different signs, like this could be positive and this would be negative, but the distance between the two is the same. But I'm going to come out with a totally different answer because Q1 is a relatively large quantity, Q2 is a relatively small quantity, and it's going to make myself have different answers. So we have a solution. The solution is to take the difference of the two variables, V2 minus V1, with respect to the midpoint, the point right here in the middle of these two. So that way it doesn't matter if I'm going this way or if I'm going this way. This part will be my numerator, and then the denominator will be this midpoint. So how do you find the midpoint of this point? If you have Q2 to Q1, I want to get that halfway point right in between, right? So the easiest way to do that is to kind of average it, right? So if this was, let's get some numbers here. If this was 10 and this was 20, then if I add 10 plus 20 and divide by 2, that's going to get me right there in the middle. It's going to get me 30 divided by 2. It's going to get me 15, which I think y'all would agree is in the middle. So the solution for the denominator then is I will have to be consistent with the quantity and the price. I'll explain that in a minute. But once I've made that decision, if I want to do Q2 minus Q1, the denominator will be, you'll love this, Q1 plus Q2 divided by 2. Or I can do Q1 minus Q2 if that's what I'm doing, if I'm wanting to be consistent in that direction. And now I'm going to take it with respect to Q1 plus Q2 over 2. Okay? Now, I'm going to show you the whole formula in just a sec, but just realize that what we are doing here with all of this whole discussion was just working on this part of the formula. So I'm going to need to do something similar to this to get that. So let's look at that now. All right, so here's our elasticity of demand formula, and what we want to do is to turn this intuitive understanding of what's written there, the percentage change in the quantity demanded divided by the percentage change in price, into actual formula that I can solve a problem for if I am given an actual demand curve. So let's look at one here. We can have one point, which will be the price of $7 and a quantity of 10. And we'll have a second point, which can be a price of $4 and a quantity of 14. Okay, so we'll name that first point P1, Q1, and the second one I'll call P2, Q2. Okay, so this is the one we want to find the elasticity for. Using our midpoint formula we were just discussing. So let's get started here. All right, so elasticity of demand. The percentage change in quantity demanded, let's do it is Q1 minus Q2 with respect to its midpoint, which is Q1 plus Q2 divided by 2. That was what we were discussing. All of this is this part here, the numerator. So to get to the denominator, we do a similar thing. Now, this is what I was referring to in the last one. Because I did Q1 to Q2, I need to stick with P1 to P2. I don't want to reverse it on the bottom here. So it doesn't matter which one I do as long as I do it the same way in both places. So I'll start with P1 minus P2 with respect to the midpoint of those two. And I know it looks ugly, I know it's scary looking, but when you understand where it came from, it doesn't get that hard to remember. So if we actually want to plug in using my example over here, our Q1, Q2, let's see, Q1 is 10 minus, and then the Q2 is 14 with respect to 10 plus 14 over 2. There's your numerator. And now we're going to look at the prices. We got 7 and 4. 7 is for the P1, so 7 minus 4 over 7 plus 4 divided by 2. And you get out your calculator and you can solve that. But let me just point out one thing real quick before we look at the solution. One of the reasons I'm harping on keeping the Q1 first, if you do the P1 first, is this is going to end up being something negative. 10 is less than 14, and 7 will be minus 4 will be positive. So this whole thing will end up negative. And it should, because it's reflecting this negative relationship of price and quantity in the demand curve. So that's what you need to watch out for. It's why you want to keep that consistent. All right, so getting the calculator out, we will find that all of this will reduce to 0.611, and I think the 1 repeats for a little while. If you come up with anything different, it might be just a slight rounding error, depending on when you're calculating this, how many decimal points you go out to. But it should be something very close to this figure. So that's how you calculate the elasticity, price elasticity of demand, using the midpoint formula. All right, one last thing I want to point out about price elasticity of demand is how it differs from slope, okay? They are not the same thing. So slope is the change in the value on the vertical axis or the y-axis or the price axis. So I'll say on the price axis since we're doing economics, divided by the change in the value on the horizontal axis, the x-axis, or for us, it's really the quantity axis. And then another way to know slope is rise over run. Okay, so slope for a line like we were looking at on the previous example would have been constant for the 2 points we were looking at, because this was a straight line and the slope is constant. But elasticity will not be constant. It's not capturing the rate at which a line is going up and over, which is what slope is doing, or in the case of this one, down and over. It is capturing a sensitivity of quantity demanded to price, changes in prices. So just know that elasticity is going to vary even along a straight line demand. A straight line demand will have a constant slope, but would have a varying elasticity of demand. And in fact, that's one thing we want to look at if we're a business trying to decide if I lower my price or raise my price, what is that going to mean for my revenue? It depends where I am on my demand curve. If I'm in a position where my elasticity of demand is 2, then for every 1%, let's see, we're going to do an increase. Let's do a 1% increase in price. I will get a 2.5% decrease in quantity demanded. Since my total revenue is price times quantity, what I'm seeing here for this particular elasticity that I just invented, oh, sorry, I did have one little mistake there. It would not be 2.5%. It'd be just 2% because I said elasticity of demand was 2. Okay, so for my business then, if I was considering increasing my prices by 1% and my elasticity at that point is 2, I'm going to lose 2% in quantity. That's now 2.0%. So every time this goes up by 1%, this falls by 2%, total revenue is going to fall. So that's how a business can actually use an understanding of their elasticity to make decisions about their prices.